Reshmi, you would see I have logged in from another device. So please make that also as co-host. I have my tablet on which I will write.
Okay.
Yeah, so please make the other account also as co-host.
Yes.
Good afternoon, sir. Vishal sir, Lekha here.
Yeah, good afternoon, Lekha.
Hi, nice to be here again.
Yeah, thank you. Thank you for coming.
Good afternoon, Professor. This is Venkat here. Thank
Hi,
you so much.
hi, Venkat. Hi, good to see you. Not see you, but hear from you.
Thank you, Professor. Thank you so much.
So Vishal, should we wait another couple of minutes?
Yeah. So there is Reshmi. You would see Professor Vishal Gupta's second account.
Yeah, we will do that.
So you can please make me the co-host. Yeah. Yeah. We can
start.
Yeah, I'm okay. Yeah.
Yeah. Okay. So let's get started. Welcome everyone to yet another edition of the research workshop series organized by the Research and Publications Office of IIM Ahmedabad. And on behalf of the Research and Publications Office, I welcome you all. And also, we are delighted to have Professor Vishal Gupta with us. And we have a very, healthy turnout and other participants are still joining. The title of today's workshop is Conditional Process Analysis in the Social Sciences. And Professor Vishal Gupta is going to, has organized and will lead this workshop. As you all know, but I would briefly introduce Professor Gupta. He is an associate professor here at the Indian Institute of Management, Ahmedabad, in the organizational behavior area. Professor Gupta also is the chairperson of the Ashank Desai Center for Leadership and Organizational Development. And he serves as the president of the Indian Academy of Management, which is an affiliate of the Academy of Management in the US. Professor Gupta previously served as a faculty member at IIM Calcutta, and he earned his doctorate from the Indian Institute of Management, Lucknow, specializing in human resources management. Professor Gupta, again, we all know, is widely acclaimed in the field, and among his many awards that he has won, he was one of India's 25 young HR leaders in 2013. He was also recognized as an emerging psychologist by the National Academy of Psychology in India, that's in 2014. And he was also conferred the Young Scientist Award in the social sciences category by the National Academy of Sciences, India, in 2016. So, he has a great deal of experience and expertise, both in academics and practice in this field. His research interests and teaching interests include leadership, justice, creativity and innovation management, research and development management, organizational theory, among others. He's widely published in these domains, and among his many publications, he's published in the Academy of Management Journal, Human Resource Management Journal, International Journal of Human Resource Management, among many other outlets. So again, it's a great delight, Vishal, to have you with us. Before I turn it over to Vishal, just very quickly, this is going to be a 3-hour long workshop, but Professor Gupta has structured it in a way that at around the 4:20 or 4:30 mark, we will have a break of about 15 minutes. In terms of general rules, we would really appreciate if you could turn off your microphones and keep your microphones turned off at all times. And if you have a question, please raise your hand, or you can even type out your question in the chat box. And Professor Gupta will take up the question when he feels it's the right moment to take up those questions. So that's about it. And without further ado, Professor Gupta, over to you.
Thank you. Thank you for having me here and for the very generous introduction, Sandeep. So welcome everybody, and on behalf of IMA, it is a pleasure, and the Research and Publication Department. So what we're going to cover in today's session is something that has become quite popular in the social sciences journals, especially journals that are focused in the domains of OB, HR, communication, strategy, marketing. We call this technique today, or the idea today, as conditional process models. Some of you would have also come across papers. So this is a broader category. This is called as moderated mediations also. So we talk about, or we have learned, maybe we have been exposed to these ideas of mediation, moderation, the phenomena. But today we actually talk about even beyond simple testing of mediations and moderation. And this category, this set of models are called as conditional process models. So what I'm going to do in today's class is maybe we'll spend the first 30 to 45 minutes reviewing and going over the theory about these models. Okay, we'll cover the theoretical understanding of these ideas of mediations and moderations and then conditional models. And then maybe in the second part of a workshop, I will demonstrate this idea through a data set. So one of my published papers, I have brought the data set, and then we'll look at the analysis. How do we write it up? How do we analyze that data? And how do we present the results? So that is going to be broadly the way I would like to approach this workshop. So the first thing is, let's spend some time reviewing the theory about these ideas, what we call as mediation, moderation, and conditional models. So I'm just sharing my screen. I hope you will be able to see that. So let me just open my writing pad. Yeah, here we go. Yeah. Okay, so now what we're going to do is, let's spend some time looking at the understanding of these ideas, which we broadly understand or call as mediation. Okay, so what I'm going to do is we'll look at the theory, the idea about mediation. Okay, so you would have come across one of the simplest models and diagrams that are typically given whenever we talk about a mediation model is something like this. So you have an antecedent variable, okay? You have an antecedent variable, you have a consequent, which is a y, okay? And we have a mediator, as we call it in our discipline. and the diagram is drawn like this. So the coefficients on the paths, the regression coefficients are listed like this. Okay, so this is a very typically drawn model of, and obviously you have the regression residuals associated with each of these variables. So this is a description of a mediation model. Now, the first thing that I want you to notice, people who are new to this idea, is what is in our research, the research projects, research papers, when do we talk about doing a mediation analysis, or why should you actually bother about doing a mediation analysis? What kind of research problem, research question does a mediation analysis answer? Okay, so the question that you have in mind that you want to answer using mediation, okay, is, I typically call it the how question. Okay, the how question, or you would also read in different research books, we call it as the process analysis. Okay, understanding the process. Now, if I were to summarize this in one word, I would call this as mediation helps us answer the how question. So if you were not testing mediation, and let's say you were only doing this kind of an analysis, you were only doing testing a path, testing the coefficient between x and y, you were interested in looking at the effect of x on y, you were saying, okay, I want to understand how are x and y related. What is the relationship between the antecedent and the consequent? That is fine. That's a good question to answer, whether these two variables are related or not. But then look at how mediation has helped in the analysis. How has mediation helped you in furthering the question or the research that you were doing? The moment you now bring in the mediator, we are able to understand, okay, there is an impact of x on y, all right, there is an effect of x on y, but then I want to understand underline the word how does x impact y? Okay, now by doing the mediation analysis, I understand that there is a direct effect of x on y. Okay, so I understand that here is a direct effect. Okay, in the terminology of mediation, we call this as a direct effect. That's the direct effect. And then, well, x also impacts y via the mediator, and this is called as, in the terminology, this is called as the indirect effect. So you would, whenever you do mediation, you always talk about, well, there is a direct effect, there is an indirect effect, and then there is a total effect of x on y. Okay, so that is the kind of analysis that you can now do. If we were just doing, just to repeat, if we were just doing the test between x and y, we were saying, well, this is the effect of x on y. But the moment I do mediation, I have broken down the total effect into a direct effect and an indirect effect. Now let me demonstrate how this happens through regression. Okay, so I would simple regressions. Let us try to get a sense of how does this breaking of the total effect into a direct and the total effect really come about. All right, so let us start by writing the equations, okay, the regression equations of these these variables. So I say, well, I will write the equation of M as an outcome. So I'm looking at this mediator. Okay, so M, I call it as well. Another thing that I'm going to do in this workshop is I'm going to follow the notation that are typically given in the very standard text of Hayes, which talks about mediation and moderation. So in case any of you are familiar or you are reading that text, my analysis, my explanation would be in sync with that book. I will share the link of the book in case you are not familiar. You may want to order it in your library or have a copy of the book. Okay, so let's write the equation. So I say, well, M, there is a constant, and then I call it as A times X plus the residual, the regression residual. Okay, that's the error of the regression. Okay, so this is a very simple regression equation for our mediator M. Okay, M is constant plus A times X plus the error. Similarly, I will write the equation for Y. If we were writing the regression equation for Y, looking at this diagram, what will it be? Let me call this as constant 1, I1, and I'll call it as I2 plus C dash times X. So that's the coefficient associated with our antecedent X, and B times M. Okay, so that's the coefficient associated with M, and then you have the residual of Y. Okay, so this is my first regression equation. This is my second. If I combine these two equations, I can say we get, what do we get here? We get Y is equal to I2 times C dash times X plus B times, and I write the equation of M here in the model, and I get I1 plus A times X plus EM plus B. Yeah, BM is already done. So what is left is E of Y. E of Y. Okay, so this becomes the combined equation. Now I can club the common terms. Well, this is a constant. Okay, I2 is a constant. It is a number in our analysis. B is a constant because it is a coefficient. I1 is going to be another constant. So the product of two constants is always a constant, and you add up. So you get a term I2 plus BI1. Okay, so this is one common term that emerges. And then let's take out the terms that are common to X. Okay, so one term is C dash. So I write it here, C dash. And then what I do is it becomes B times A into X. So I'm going to write it as AB times X. And then, well, EM and EY, they are both random numbers. They are residuals. Okay, it's a random series. And a constant multiplied with a random series is a random series again. So I can club these and they become my residual of they represent the residual of my overall regression equation. So I can write this equation as some constant I plus C dash plus AB X plus M a residual. Okay, and let's call it as E of Y. Again, this E of Y would be different from this E of Y, just for notation. Now you see, if we were to do a similar regression between just X and Y, okay, if I was to just do one regression, I was interested in looking at how is X related to Y. Let's call this constant as coefficient as C. Okay, let's call this path coefficient here as C, what will I get? I will get y is equal to I plus Cx plus E of y, some residual associated with y. So if we were to compare these two equations, okay, if you compare these two equations, it can be said, therefore, it can be said that here C, which is called as the total effect, okay, this is the total effect of X on Y, okay, this is the total effect of X on Y. If there was no mediator in the analysis, it was C. What have we done? When we brought the mediator in the model, the coefficient of X is Y. So we can say that C here is equal to C dash plus AB, because this is also representing the coefficient of X on Y, and this is also representing the coefficient of X on Y. And this is the fundamental equation that is written to understand how the effects get broken down when you bring in mediators into your model. So this C dash is called as the direct effect in the presence of the mediator. What is the direct effect of X on Y? And this product A to B, this product A into B is called as the indirect effect. So what have we done? There are two things that I would want to mention here. If we go back and look at this model that we started with, what is this? The direct effect is very straightforward. It is C dash. And what is the indirect effect? Indirect effect is the product of all the path coefficients that you meet when you travel from X to Y. Okay, what I have just demonstrated is that the effect, how the effect is computed using regression, but pictorially also we start from X, go to M, so that we meet the first coefficient, which is A. We start from M, go to Y, and we meet the second coefficient, which is B, and the product becomes A into B. So there is this indirect effect. What have I achieved by testing this? Up till now, I was only talking about X is related to Y. But now I can say that X is not just related to Y directly, but it has an indirect influence. So for example, if you were to say leadership impacts performance of individuals, of employees, leaders impact performance. Well, that is okay to say leaders impact performance. But what is it that leaders do? What is it that leaders do to actually impact performance? And that is they impact, let's say, justice perceptions. Okay. Leaders impact perceptions of fairness at the workplace. So one of the mechanisms that leaders can deploy to impact performance is to create fair workplaces, or to impact perceptions of fairness for employees, and that may have an indirect influence on performance. So that is what the mediation tries to do or tries to achieve when we are doing this kind of an analysis. Okay, so if you are doing your mediation papers, okay, these are fundamental building blocks for conditional models. If you are going to do your mediation models, you will have to prove what is the test of mediation. The test of mediation in any research that you do, in any research paper where you are going to you are talking about mediation models. In those papers, one is, yes, you talk about whether A is significant, B is significant. You will get it through your regression equations, right? You can find out whether my coefficient A is significant, whether my coefficient B is significant, and that is good. And your C dash, which is the direct effect. But then that is not the test of mediation. Okay, if you just leave it at that, journals and reviewers will come back to you and say, well, that is not the test of mediation. So what is it that you will have to do when you are going to test for mediation, or when you are writing about mediation? You will have to show that this product, the product, I'm calling it as the true, that is of the population, A true A and true B, that is the product A into B in the population will be 0, or will it be different from 0? This is A and B here. I'm denoting these are sample coefficients. But what about the population? In the population, will this term be, the product would be 0 or not? Okay, so that is what you will have to prove. You will have to talk about, irrespective of what happens to your direct effect. We are not concerned with what is happening to direct effect here. If you have to talk about mediation, that there is a significant mediation in my research, there is a significant mediation in this happening here, you will have to talk about what is happening to your indirect effect. Is the indirect effect significant or not? Now, how do you do it? I will not go into detail here because we don't have the time. There are two ways to test the significance of indirect effect. The first one is called as the Sobel's t-test, which is given by t is equal to A into B divided by the standard error of the product term AB. Okay, so you know A, and here A and B, mind you, they are unstandardized coefficient, unstandardized regression coefficient. Okay, you will get it from your analysis here. Okay, from your regression test, you will then take the product, okay, A into B, and standard error AB is not given, so there is a formula. So we say A square into standard error of B square plus B square standard error of A square. So this is the formula. Again, we don't have to compute it. Today we have softwares that give us these results automatically. Okay, and so this has been found. This follows a t distribution with n minus k minus 1 degrees of freedom, and so you look at the p-value and test it against your alpha and make the conclusion whether your indirect effect is significant or not. Okay, but then there are criticisms of Sobel's t-test because simulation studies, Monte Carlo studies have shown that this product, okay, this test is assuming that the product A into B follows a normal distribution, okay, which have been found to be violated. Okay, that does not hold good. And studies have shown. So the second way, which we will also see when we will do our analysis, is what we call as bootstrapping. Okay, bootstrapping method. So today we typically, whenever there are doubts about our normality assumptions, we typically report not just the normal theory test, but we also report the bootstrap results in order to account for whether our coefficients or the indirect effects are significant or not. Okay, so two things that we will keep in mind through what I have said so far is mediation helps us answer the how question, understand the process. It helps us break the total effect into the direct and the indirect effect. And then whenever you are writing or going to talk about mediations in your research paper, you will have to show that the indirect effect is significant. Okay, what happens to the direct effect is not important. You have to prove, you have to show through your analysis that the A into B is significant. All right. Now, the good thing about, if once you understand this simple mediation model, actually, and again, I will not do it because we don't have, that is not typically the focus here. But this idea of mediation, of this kind of analysis, can be extended to multiple mediator models also. Okay, the way of analyzing this this model that we have just done. So again, today researchers they look at multiple mediators. Okay, testing the process, trying to understand the process. So you have not just one mediator, you may have more than one mediator. Okay, and this is your direct path. We call this as C dash. This is, let's call this as coefficient A1, B1. Let's call this as A2, B2. Okay, so now this is a multiple mediator. And by the way, this is called as a parallel mediator. So you may read some papers, some of you may be working on these kinds of models. This is called as a parallel mediator model. Okay, now if you have understood the first model that we just did, the one mediator model, understanding multiple mediator models is a cakewalk. You can say, what is the direct effect? Well, my direct effect in this model is C dash. This is my direct effect in the presence of mediator. The indirect effects. Okay, now there are going to be multiple indirect effects because there are multiple mediators. Okay, so you have one path. You start from X, go to Y via M1. Okay, so it becomes A1 times B1. Okay, the other path goes via the second mediator. Okay, and so you have another indirect effect, that is A2 times B2. And so your total effect now here. Okay, so your total effect is given by C dash plus A1 B1 plus A2 B2. Okay, and you can test, you will have to show that these indirect effects are significant in order to prove that your mediator M1 and mediator M2 significantly mediate the model that you are looking at, the process or the relationship between X and Y. Okay, so this is called as a parallel mediator model. Then there are another kinds of papers that are being done today, okay, and they are becoming more popular. They are called as sequential mediations, okay, sequential mediator models, okay. Sequential mediator models. Now, what happens in a sequential mediator model is you have X, okay, and you are testing its relationship with Y, okay, so I call this X and Y. And then now I have again, let's take up the case of two mediators, so M1 and then M2. Now what happens is, these are arranged sequentially. So X is related to M1, M1 is related to M2, and M2 is related to Y. Okay, so this is, or here X causes M1, M1 causes M2, M2 causes Y. And then you also have the direct paths emerging from these variables. So this is called as a sequential mediator model, where they are not arranged parallelly. They are in this model, they are parallel, right? Here, both these mediators are not related to each other. But here there is a relationship between the two mediators also. So we call these as A1, okay? This is A2, this is B1, this is B2, this is C dash, and then let's call this as path from 2 to path regress D to 1. So path from 1 to 2. So what is the direct effect again? The direct effect here, these can all be proved through regression, writing regression equations, okay? And there are now going to be 3 indirect effects, okay? So the first indirect effect is going to be this. The second indirect effect is going to be this. And then the third indirect effect is going to be all the way from X to M1 to M2 to Y. Okay, so that is how we understand, and once you get your regression output, you can do this computation yourself to figure out what would be the indirect effect between the X and Y. So this is the effect of X. What is indirect effect? Indirect effect is nothing but the effect of X via M1 and M2, or via M1, just via M1, just via M2, or both M1 and M2. So there are going to be here 3 indirect effects, A1, B1, A2, B2, and then A1 product D2, 1 product B2. Okay, and you can again test the significance of each one of these using either the Sobel test or the bootstrap method, and report that these results or these coefficients or these effects are significant, and therefore there is an indirect effect. There is a via effect of X through these mediators. Okay, so that's the whole thing that we would want to look at when we talk about mediation. Now let's come to the second very important phenomena that we look at, which is called as moderation. Okay, so this was all about mediation. Now we talk about what is moderation. If I were to summarize the whole idea of moderation testing or moderation models, I will use the word when. Okay, so remember, the mediation asks the question how. Okay, how does X impact Y? How is the influence of X happening on Y? So what are the via medium? What are the mediating variables? What is the process through which X is impacting Y? In this case, what we are doing is we are not looking at breaking down the total effect. Rather, we are looking at when will the effect of X on Y be different. Okay. In mediation, we said C is equal to C dash plus AB. Okay. So we said that the total effect does not change because of the mediator. This will add up to still remain C, the total effect. That is what was happening in mediation. But now in moderation, what we are going to say is, or what we are going to do is, when will the total effect itself change? How will or what would be that boundary condition. So we typically call this as exploring boundary conditions in our processes, in our phenomena. Quantitatively, we call it as what is the boundary condition for my phenomena? What is the boundary condition for my relationship between X and Y? Now, the first thing that you should remember or you should note is when we talk about moderation, okay, a moderation model is always drawn like this. I review a lot of papers where people are confused between the representation of moderation and mediation models. Okay, so they will talk about a mediation model but draw it like this, or they will talk about moderation but they will draw it like a mediator model. So please note that this is how a moderation model is conceptually represented. Okay, this is the conceptual representation of a moderator model, okay, of a moderation. Do not get confused between a moderator representation and a mediation representation. Okay, so if this is the conceptual representation, how is this studied? What is the statistical, or how will we understand it, okay, in our statistical analysis? So we call it as the statistical diagram or statistical representation. And so you break this, or you open up this model, okay, you have X, you have Y, and you have a path from M to Y, and then you also regress Y on X into M. You regress Y on the product of X and M. Okay, and we'll write these coefficients. Let's write these coefficients as B1, B2, B3. This is the error associated with. Okay, so what is the equation? How will I write the regression equation? I will write it as Y is equal to some constant I plus B1 times X, B2 times the moderator of my model, and then B3 times X into M plus the residual of the regression E of Y. Okay, so this is the representation. If I combine the terms, so I can write it as I plus B2 times M plus B1 plus taking out the terms common with X, so I call it as B1 plus B3 M times X plus E of Y. Okay, now look at this, and this is where it becomes really interesting when we start talking about moderations. Okay, look at what has happened. If I were to say what is the effect, so let me denote the effect of X on Y by theta. Okay, so I call it as the effect of X on Y. Now it has become what? What is the regression coefficient? It is B1 plus B3 times M. B1 plus B3 times M. Okay, so again, emphasizing that when we were talking about mediation, we always said that the total will add up. The direct and the indirect will add up to be C. Okay, so what we are doing in mediation, we are just breaking down into two terms, the direct and the indirect effect. But then what does moderation do? Moderation says no. I'm not just looking at breaking up of the term. What am I doing here? I am saying that the effect of X on Y has now become conditional on M. Okay, so we call this as the conditional effect. The conditional effect of X on Y. Okay, so that is my conditional effect. So the effect that X was having on Y. And this is a beautiful idea to do in research. You see, there are, and especially in our discipline, in management, in social sciences, typically what we do is we study relationships, we talk about theoretical frameworks. Now, what is moderation helping us to think? Moderation is telling us, well, you see, X to Y is related. We know from prior literature. We know that X to Y is related in maybe in Western context. This is how it happens. But then when I'm talking about India, when I'm talking about my specific context, either industry context, either work context, cultures, okay, different cultural context, what I am saying that the relationship of X and Y is not what we have found in the Western context. Rather, there is a moderator. There is that moderator could be anything. It could be individual personality. It could be, as I said, cultures. It could be industry context, etc., etc. There are variables that will change how X and Y are related. They can either enhance the effect, they can either enhance the relationship, they may also diminish the relationship between X and Y. And that's a powerful idea, because what you are saying is, I am not denying the theory. I am not denying the theory. I'm not saying that the theory is junk. What am I saying is, while agreeing that X and Y are related, I am adding a nuance to the theory. I am adding a condition. I'm adding a boundary condition to this theory, to this argument that X and Y are related. But in my context, it may be actually more pronounced. It may be pronounced. It may be higher, or it may be lesser, and so on. So remember, okay, remember in moderation, your effect of X on Y will always change, Whereas in mediation, it will always remain the same. Mediation helps you partial out the effect, break down the total effect into direct and indirect. Moderation actually helps you figure out when will the effect be pronounced or not. Okay, so that is one thing. Now, what is the test of moderation? Like we did the test of mediation, how or when will you say that there is a moderation in my model, there is a moderation in my analysis, okay, in my research that I am doing, in my data? Okay, so we call it as test of moderation. So if you look at this equation that we have written here, okay, this equation that we have here, when will the effect be conditional? When will the effect of X on Y become conditional on M? It will become conditional on M when my B3 is significant. My B3 coefficient is significant in the analysis. If B3 is not significant, for example, if B3 was to be tied at 0, what will happen? It will become theta X to Y would become B1. Is this conditional on M? There is no M term here. Okay, there is no M term. Therefore, the effect is unconditional. Okay, it is always going to be B1. It is B1. It's a constant B1. So the moderation exists only and only if your B3 is significant. Okay, the coefficient of, and what is B3? The coefficient of the interaction term. Okay, interaction term is significant. Remember, okay, I'm repeating, remember, irrespective of what is happening to B1 and B2, irrespective of what happens to B1 and B2, moderation will exist if B3 is significant. So a lot of people, students that I work with and other researchers, they talk to me and say, well, Professor, the coefficient of X or the moderator is not significant, and so my moderation is not going to be significant. Well, that does not matter. What happens to B1 and B2 does not matter. Okay, you've got to be interested in checking what is happening to the interaction term, because that is going to change the effect. So the test of moderation is only and only if your population parameter B3 is different from 0, is not equal to 0. That is when we will say there is a moderation. Okay, and that is very simple. Here you don't have to do anything. The regression output will tell you whether this coefficient is significant or not. Okay, just one last thing while we are on moderation, you will also have to do one more thing. Whenever you do a moderation paper, you would see that in a moderation paper, there is always a plot that is done. Okay, we call this as moderation plots or interaction plots. Any paper in any discipline, OB, HR, marketing, strategy, communication, any of these disciplines, whenever you talk about moderation, you will always have to plot how is the relationship between X and Y changing for different values of moderation. So we call this as an interaction plot. Okay, interaction or moderation. Okay, and so there would be no moderation paper is complete without such plot. So what you do is you plot the line. Okay, so I say, well, this is my line when I say y is equal to I plus b1 x plus e of y. This is when m was 0. Let's say moderator was 0. And then I plot another line here and I call it as, this becomes y is equal to I plus b2. So this becomes my intercept of the line and I get b1 plus b3 x ey. This is when m is equal to 1. I'm assuming your moderator is dichotomous. It takes two values, 0 and 1. So if you plug it in this line, b2m, okay, this was one term, and then we got b1 plus b3m times x plus e of y. So you can get these two lines. Y when m is equal to 0 is I plus b1x, and y when m is equal to 1, you get b1 plus b2, b1 plus b3 times x. Obviously, all of this plot that I have shown are with an assumption that all these coefficients are positive. Okay, they are all greater than 0. If these polarities change, if the signs change, if they become negative, then your plots will change. Okay, so this is your constant I, this difference between the two lines is going to be B2. Okay, the slope of this line is B1, and the slope of this line is B1 plus B3. Okay, that is, so you will have to show, and the visual test of moderation is that the two lines diverge or converge. They are not parallel. Okay, they should not be parallel. If they are parallel, then it means that this term is zero. This term is not significant, and therefore the lines are parallel to each other. Then there is no moderation effect that is happening here. Okay. So this is all that you would do, or you will have to do whenever you are going to do moderation paper. So what we've done so far is we've tried to cover the mediation idea. Okay, so the mediation helps us answer how, moderation helps us answer when in our research. Now, with this background, with this foundation, let us come to the idea that we are all here for, which is the combination of these two terms and these two ideas, which combined today in research, they are called as moderated mediations. Okay, so understanding of mediation and moderation is important in order to understand this term, which we call as moderated mediation. Okay, this is also called as conditional process analysis. Conditional process analysis. Now, if you have understood mediation and moderation, you would be able to understand what are we talking about here. We are talking about process analysis. Okay, so what was process analysis? I just told you process analysis is mediation. Okay, so mediation is actually telling us, understanding, helping us understand the process. Okay, now moderation talks about the boundary conditions. Okay, the idea of moderation, which we just covered, is moderation talks about the boundary conditions for our phenomena, for our relationships that we are trying to test. When you combine both these ideas, when you relate both these ideas, you get moderated mediation, or what we call as conditional process analysis. Okay, now let me demonstrate what is it that I have in mind and how does this actually work. So let's say we are talking about our original relationship that we wanted to understand. How is X related to Y? What is the relationship between X and Y? So we test this path. Okay, we wanted to understand the process, so therefore we brought in our mediator. Okay, now what have we done? We have done the process analysis bit. We are now it is now possible to understand what is going to be my direct effect, what is going to be my indirect effect. So I'm now doing process analysis. But then I'm saying that the process is also conditional. The process is also conditional. There is the mediated, the mediation is also moderated. Okay, the mediation is moderated. If I draw an arrow like this, I'm saying now, let's say, I will give you multiple scenarios here. Okay, Let's begin with a simple uh, uh, model here where we are saying, let's assume there is a variable W that moderates the path from X to M. Okay, it can moderate other paths also, but here I'm for simplicity, I'm just assuming that the variable moderates this path between X and M. So what have we done? You see, this becomes a representation of, there is a mediation, okay, which was here. This is our mediation. And here, what have we done? We have brought in the idea of moderation. So there is a combination of, so this was our mediation analysis, and this is the moderation. Okay. Now, what am I trying to achieve? Why am I drawing these fancy diagrams? What is it that I am trying to do in my research? Why should we even be bothered about drawing or doing such kind of analysis? So let us see what happens if I were to draw this kind of a diagram. Okay, what is the kind of question that I'm trying to answer? What is your research question for which you should actually be doing conditional process analysis? Why should you be even bothered about this kind of a diagram? Okay, so if I say, let's say we have X, we have our variable Y. Okay, this was our conceptual diagram. Let's try to do the derivation. Let's try to do the regression equations here and see what is it that we are getting. Okay, let us open this moderation, and we have seen that whenever there is a moderator, we always draw a path from W, from the moderator, and then we also bring in the product term X into W. Correct? This is what we had done. If you remember, if you look up your notes, or if you remember, we had opened up the conceptual diagram and we had drawn the path from moderator to the outcome, and then the interaction of the antecedent and the moderator to the outcome. So here, because W is moderating the relationship between X and N, this is how I draw it. And then the other path, I draw it as it is. Okay, so this path I call as C dash, as I was calling earlier. This path I call as B. Okay, this coefficient was A. Now it has been broken down or opened up into three parts. So I call it as A1, A2, and A3. This is how I write this, or this is the statistical representation. Diagram that I draw. Okay. Now, if I were to write my equations here, what will I say? I will say, well, M is equal to I1, some constant plus A1x, A2W, A3x into W plus the residual associated with the outcome. And then, so I can simplify this and I can say Y is equal to I1 plus A2W plus A1 plus A3 times W multiplied with X and E of M. So this becomes my first equation here. Then what do? I write my second equation, which is the outcome Y, and I say Y is equal to some constant I2 plus B times M plus C dash times X plus the residual associated with the outcome y. Now, if I combine these two equations, what do I get? I get combining 1 and 2, we get m is equal, y is equal to, I'm substituting m in y, what I get is I2 plus. Now let's multiply b with this equation m, which is I1 plus A2W plus A1. Let me multiply whole of this, A1 plus A3W times x plus E of m plus C dash x plus E of y. Okay. So what do you get if you expand this equation? You get I2 plus b times I1 plus A2W. Okay. So this becomes one term. Okay. This is for different values of W, we will get different intercepts. So this becomes the common, the intercept term. And then what do? I get b times A1 plus A3W, and I'm going to bring in C also because I want to club the terms common to x. So I say plus C dash, here this is x, okay, and I get the residuals E of y plus b times E of m. This is what I get when I start to solve my regression, my equation here. So I can write my overall in this form, y is equal to I plus cx plus ey, and I can say that my c here is equal to c dash plus b times a1 plus a3W. Now this is the key result that we were doing all this thing for. Okay. Now this equation, the first thing that you should look at is that this is a mediation equation, right? So what have we said? We have said that the total effect C is broken down into a direct effect. There is a direct effect C dash, and there is, so this is the direct effect of x on y, and this term is the indirect effect of x on y. And not just that, this indirect effect of x on y is actually conditional upon W. If you see, what have we got? This indirect effect now is conditional upon x. So what is the research question that we have answered? What is the research question that we have answered now, or we are trying to answer, or what is it that we are trying to achieve through these conditional process models? Is we are saying that, well, x impacts y via this term, via the mediator. Okay, so there is an indirect effect of x on y via the mediator. That is okay, right? So that is the That is the indirect effect here. But then indirect effect also has a boundary condition. It is not unconditional. Under certain circumstances, the indirect effect can become higher. It can also become lesser. What is the indirect effect here? The indirect effect has become A1 plus A3 times W multiplied with B. When let's assume W to be dichotomous, so it can take two values. So when W is equal to 0, indirect effect is A1B. A1B. When W is 1, you get your indirect effect as A1 plus A3 times B. So now we are saying, what have we done? We have identified, or we have discovered one more insight about our phenomena. What is the insight about the phenomena? The insight is that the process that I was talking about, the indirect effect that I was talking about, that also does not remain unconditional. If I have one particular condition, then X has a greater impact, greater indirect impact on Y via my mediator. Under other circumstances, X has a lower indirect effect. X has a lower via medium effect on Y. So what is it that the conditional process model helps us achieve? So you can now visualize in your, just think about this term, conditional process analysis. So we are doing process analysis through the mediation, and then we add the condition to the mediation, condition to the process, and so it becomes conditional process now. It has become conditional indirect effect. Okay, or we in our research papers, you would, and I will show you some papers of mine, we call these as moderated mediation models, okay, where the indirect effect is moderate. So let us look at another example, okay? Let us look at another example before we take a break, and then we'll come back and do an example, okay? Let's look at this model. Okay, so I have X, I have Y, okay, I have this mediator. So I'm just taking a simple example, so that simple one mediation example, not the parallel, but these ideas can be extended to multiple mediator models as well. Okay, this is A, this is C dash, this is B. Okay, now I want all of you to do this diagram. Okay, draw this diagram and let us try to analyze what will be the direct and the conditional indirect effect here. Okay, now this is the concept. This is how you will draw in your research papers. Okay, when you will be, so this is the conceptual diagram. Now let's see how we will open this up and draw our statistical diagram. Okay, what will be the equivalent statistical diagram for or representation of this model? Okay, so we have X, we have M, remember when you have moderation, how will you open it up? So you have this y here, the path from the mediator comes, and then we have the moderator. So we will have the path from the moderator, and we will have path from the interaction term m into v. Right? Remember how we used to open the moderation, okay, the moderator diagrams, okay? So you have the path from X, you have the path from the moderator, and you have the path from M into, or the antecedent and the moderator, the product of the antecedent and the moderator. So we call this as A, we call this as C dash, okay? And because this is B, so now I open it up and I call it as B1, B2, and B3, these coefficients, okay? Now, if I were to now write, simply show you the regression equations here, what will it be? M will be very straightforward. So it will be I1 plus A times X plus E of M. No difficulties, no complexities here. Very simple, one variable, I1 plus AX plus E of M. And then you have Y, which is I2 plus C dash X, okay, the direct effect. And now you have B1M, B2V, and B3 times M into, okay, plus E of Y. Okay, so you have this B1 plus B3V times M plus B2V plus E of Y. And now what we are going to do is we are going to substitute 1 into, okay, so we are going to put in key in the equation of M. So what is it that we get? Y is equal to I2 plus C dash X plus B1 plus B3V multiplied with I1 plus AX plus EM plus B2V plus E of Y. Okay. Now let's open this up. So we'll keep putting together. So we'll put this term together with I2. So we'll call it as I1 times B1 plus B3V. Okay, so this is one term now. Then let's put the term with X together. So it will be C dash, which comes here, plus A times B1 plus B3 V, okay, whole times X, okay, and here, yes, B2V also goes here, B2V will also come here, and then you have the error terms EY plus EM B1 plus B3 V. Okay, now if we were to compare this equation with our overall total effect equation, Cx plus E of Y, what will it become? C is equal to C dash plus A times B1 plus B3 V. This is the key result here in this kind of a model. So what have we done? We have got the direct effect is this is the direct effect. And now this term represents the conditional indirect effect. This term represents now the conditional indirect effect. So there is not just one indirect effect. Now this indirect effect is now conditional upon the value of V. the value that V takes. Okay, so your indirect effect, when V is equal to 0, what will it be? A times B1. Indirect effect, when V is 1, V becomes 1, or V takes a value of 1, what will it be? It becomes A times B1 plus B3. So again, what are we trying to do now? We are saying that our indirect effect, our process now, okay, the understanding of process, the process that we are looking at is not unconditional. Okay, the indirect effect is not unconditional. It is actually conditional upon the value that V is going to take, because V moderates this path. Okay, now just an interesting fact, or just for your clarification, tell me, all of you, if you are with me up till now, tell me if you have a model like this. If you have a model like this, okay, is this conditional process analysis? Is this a conditional process model? Is this an example of moderated mediation?
No.
This is not.
No.
This is, yes, you are all, yes, I'm happy you are with me. This is not, this will not be called as conditional process analysis, because what you are doing, you are only talking about the moderation of the direct path. So this is not moderated mediation. This is not a class of moderated mediation. This is only talking, if you were to open this up, okay, if this is our conceptual diagram, if this is our CD conceptual diagram, the statistical diagram is going to be X to M to Y. Okay, then you will have an effect from W to Y, and you will have an effect from X into W to Y. This will continue to be A, this will continue to be B. We can write this as C1, C2, C3. Okay, but here there is the indirect effect. Indirect effect here will be only A into B. You will have a conditional direct effect, that is all right. You will have a conditional direct effect, which I can tell you will be, you can write down the equation and verify, this will be your direct effect, C1 plus C3W. This will be the theta X to Y conditional upon W, but you will not have a conditional indirect effect, and therefore this will not be an example of moderated mediation. Let us do one last example, and that would cover up the theory that I wanted to talk to you here. Let's look at this one last diagram, and I will encourage all of you to try to solve it on your notebooks, okay? And let us solve it together. So I have this model now. You may see some papers talking about models like this. X to M to Y, okay? So you have, this is our indirect effect, sorry, this is our direct effect, C dash, and then I have a W here, I have a V here. Okay, this is my so we have so far seen with only W, with only V, but this is the last kind where even you can have moderators on both paths. Okay, you can have moderators on both the paths. And how will it look like? Okay, so the first thing that we do in always is we start by doing our statistical diagram. So let's open how the regression equations will look like. Okay, so we write x to m, w to m, and then x into w to m. Okay, so this is my x, w, and x into w. Then I write my path from m to y. So this is y. Then I draw a path from v, and I draw a path from m into v. So I open this moderator also, and I call this. So I call this as a1, a2, a3. These coefficients, I call this as b1, b2, and b3. Okay, so I'm just, what we have been doing so far, I'm just replicating it for both sides. And this effect continues to remain C dash. Okay, so what is it that we can write? So M we can write here is I plus I1 plus A1 plus A3 W times X plus A2. Okay, let me write it. Let me not. So let me write it as A1X plus A2W plus A3X into W plus E of M. So it becomes, my M becomes I1 plus A2W, A1 plus A3 times X. So I can say my conditional effect of X on M, okay, which is conditional on W, can be written as A1 plus A3, right? This is my effect of X on M, and that is conditional on W, okay? So this becomes my first equation here. Similarly, I can say that y is equal to I2 plus C dash X plus B1M, B2V, B3M into V, that is another interaction term, and then E of Y. So if we club the terms together, B2V comes together here, okay, then we have the C dash X term, and I can say B1 plus B3V times M plus E of. Okay, so just simplifying this equation. So what is the theta M to Y? Okay, the effect of M to Y. Now this is conditional on V, and that is given by B1, this term, B1 plus B3. B1 plus B3. So this is the effect of X on Y, X on M is this, effect of M to Y is this. So what is the total indirect effect? The total indirect effect of theta X to Y conditional on W comma V can be written as theta X to M conditional on W multiplied with theta M to Y conditional on V. So because we have seen what is our indirect effect is always the product of the effect of X to M and then M to Y. Okay, so what is it going to be? It is going to be a product of A1 plus A3W multiplied with B1 plus B3 V. And this is now your indirect effect, which is conditional on two moderators. Two moderators, okay? A1 plus A3W, B1 plus B3, B1 plus B3V, and your direct effect continues to remain C. What is your total effect? It is going to be C plus A1 plus A3W and B1 plus B3. This becomes our total effect. So what have we got? Because there are two moderators, you have again a conditional indirect effect, and which is denoted by this. This is our conditional indirect effect. So again, to emphasize, we talked about mediation. Mediation helps us talk about the process, the how. Moderation helps us talk about the condition, the when, okay? And conditional process talks about when is the indirect changing, or when will the indirect itself change depending upon the condition, which is the moderation or the moderator that is there. Either it could be from X to M, it could be from M to Y, or it could be at both X to M and M to Y. And then you will have, in all these cases, you have conditional process, conditional indirect effect, or moderated mediation. Okay, so let us take a break here. This is all that I would like to say in terms of the theory. Now what we will do is we will come back. Okay, it is about 4:35. Let us come back at 4:50. Okay, in about 15 minutes time. And what I'm going to do is I'm going to upload in the chat a zipped file. Okay, so in the 15 minutes, I will request all of you to please download that zip file. Okay, and then I will demonstrate working on SPSS. Okay, so I will request all of you, in case you have SPSS installed on your machines, you may download the files, launch your SPSS, and then I will demonstrate how do you actually do this, and we'll take up a data, we'll look at the result, I will tell you how to analyze it, how to interpret it, and I will share with you in that zip. I will be sharing some papers, you can read further on it. Yeah, okay, so let us take a break and we'll come back at 4:50.